The engines fall silent. For the first time in 7 months, the vibration leaves your bones. The spacecraft settles. Hydraulics hiss. Somewhere beneath you, the landing legs absorb the last of the momentum. And then, nothing. Just the low hum of life support and the sound of your own breathing inside the helmet. You are on Mars. Outside the window, the light is different. Softer than you expected. Dusty. It filters through an atmosphere so thin it barely deserves the name, painting the landscape in shades of ochre and rust. The horizon curves close. The sky is not blue. It is the color of weak tea at dusk, even though it is midday. There is no wind. Not really. What passes for wind here would barely stir a candle flame on Earth. But you can see its work in the ripples of dune fields stretching toward the southern highlands, in the slow burial of rocks over millions of years, in the way the dust clings to everything, fine as talcum, fine as smoke. You are the first human to stand on another world. And for a moment, just a moment, it feels like victory, like every line of history has been leading to this footprint in the red soil, like the species that learned to walk upright has finally learned to walk across the solar system. But you are not a tourist. You are not an explorer in the romantic sense. You are a biological organism, wrapped in a thin layer of engineered fabric, standing on a planet that has been trying to kill you since before your ancestors first sharpened stones. The suit is all that separates you from vacuum, from cold so deep it would freeze your blood in minutes, from radiation sleeting through an atmosphere with no magnetic field to stop it. And yet, none of those are the real problem. The real problem is already inside the habitat, already settling into the seals of your suit, already working its way into the machinery that keeps you alive. It has been waiting for you for billions of years, silent, patient, and utterly indifferent to your species' greatest achievement. You breathe. The suit circulates oxygen. The readouts on your wrist display green. For now, when we imagine sending humans to Mars, we tend to focus on the dramatic dangers, the ones that make for good movie trailers, the ones that feel like problems we can solve with enough engineering and courage. The journey itself, for example, 7 months in a metal can no larger than a studio apartment, drinking recycled water and breathing recycled air, while cosmic radiation slices through the hull and through your cells. The human body was not designed for zero gravity. Muscles atrophy, bones leach calcium, fluid pools in the head until your optic nerves begin to swell, reshaping your eyeballs from behind. We know this. NASA knows this. The engineers at SpaceX and ESA and every space agency on Earth have spreadsheets full of countermeasures, exercise regimens, pharmaceutical interventions, artificial gravity, if we can afford the mass, radiation shielding, if we can afford the weight. Then there is the landing, the infamous 7 minutes of terror that has claimed more than half of every robotic mission ever sent. The atmosphere is too thin for parachutes alone, too thick to ignore. The math of entry, descent, and landing on Mars has been called one of the most difficult problems in aerospace engineering. A human-rated lander would need to be larger, heavier, more complex than anything we have ever attempted. But we are working on it. Sky cranes, retropropulsion, inflatable decelerators. The problems have definitions, and definitions imply solutions. And once you are down, safely down, there are the visible threats. The temperature swings of 60 degrees between day and night. The ultraviolet radiation that would give you a sunburn in minutes if the atmosphere were thick enough to allow it. The soil chemistry, perchlorates, toxic to the thyroid, corrosive to skin. The low pressure that would boil your blood in the absence of a suit. All of these are real. All of these are serious. And all of them share something important. We can see them coming. We can measure temperature. We can calculate radiation dose. We can design suits that maintain pressure, filters that remove perchlorates from the air. The dangers of Mars, as we currently understand them, are dangers we know how to model. But models are only as good as their assumptions, And there is an assumption buried so deep in our planning that almost no one questions it anymore. An assumption about the relationship between the planet and the machinery we bring to it. An assumption about what happens when human technology meets an environment that has never encountered human technology before. The assumption is this: that we can keep the outside out, that the habitat will remain sealed, that the suits will remain intact, that the filters will hold, that the boundary between Earth and Mars is something we control. Mars has other ideas. They are very small ideas, microscopic in fact, and they have been waiting quite patiently for someone to bring them inside. The dust on Mars is not like dust on Earth. On Earth, dust is mostly organic. Skin cells, pollen, fungal spores, fragments of insects, minerals ground down by water and wind. It is alive in a sense. It contains the residue of billions of years of biology. Martian dust contains none of that. It has never known life. It has been sterilized by ultraviolet radiation for billions of years, blasted by cosmic rays, ground by ancient impacts and endless wind into particles so fine they behave almost like a liquid. The average grain size is 3 micrometers, 1/20th the width of a human hair, small enough to pass through the finest filters, small enough to stay suspended in the thin atmosphere for months, small enough to get everywhere. And it is electrostatic. Mars has no global magnetic field. The surface is constantly bombarded by solar wind and radiation, transferring charge to the dust particles. They cling to everything. They cling to each other. They cling to your suit, your visor, your solar panels, your radiators. During the Viking landers in the 1970s, engineers watched in frustration as dust accumulated on the solar arrays, dropping power output by 80% within months. They had predicted some loss. They had not predicted that. But that was robotics. Robots can lose power. Robots can be designed with redundancy, with margins, with acceptance of eventual failure. Humans cannot. The dust does not care about the difference. It gets into the habitat, not through dramatic breaches or hull failures, through the simple act of entry. Every time an astronaut returns from the surface, their suit carries dust. It is impossible to brush off completely, impossible to vacuum away in the airlock. The electrostatic charge means it adheres with a force far greater than gravity. It clings to fabric, to metal, to seals. And when the airlock cycles, when pressure equalizes, when the inner door opens, the dust comes inside. Now it is in the breathing air. Now it is in the water recycling system. Now it is in the electronics. And this is where it gets worse. The dust is sharp, not like sand, which is rounded by tumbling in water. The dust on Mars has never known water. It is fractured, angular, jagged at the microscopic level. Every particle is a collection of tiny blades. When it gets into machinery, it abrades. When it gets into seals, it compromises them. When it gets into lungs, we do not actually know what happens when it gets into lungs, because we have never studied the long-term effects of Martian dust on human tissue. We have simulants, made from terrestrial volcanic material, ground to approximate the composition. But simulants are not the real thing. Real Martian dust contains reactive compounds. Perchlorates, yes, but also silicates that can cause something like silicosis if inhaled, and trace elements we have not fully characterized, and a surface chemistry altered by billions of years of radiation exposure, creating free radicals that could damage cells in ways we do not yet understand. The human body has defenses: cilia in the airways, macrophages in the lungs, mucous membranes designed to trap and remove foreign particles. But those defenses evolved on Earth, for Earth particles. They have never encountered anything like this. The dust is not alive. It does not need to be. It is simply a physical fact of the Martian environment. And every hour spent on the surface, every exploration, every sample collected, every return to the habitat, it accumulates. Filters clog, machinery grinds down. The fine dust works its way into bearing surfaces, into electrical connectors, into the moving parts of life support systems that cannot afford to fail, and into the astronauts themselves, where it will remain, because the dust is not coming out. Once it is inside the habitat, inside the suits, inside the lungs, there is no way to remove it. No vacuum cleaner fine enough, no filter dense enough without restricting airflow, no medical procedure that can extract particles embedded in alveolar tissue. The first human mission to Mars will not end with a dramatic explosion, or a hull breach, or a sudden loss of oxygen. It will end with the slow, silent accumulation of something we cannot stop. The first symptom is irritation, a scratchiness in the throat that does not go away, a dry cough that worsens over weeks. The astronauts assume it is the recycled air, the lack humidity, the familiar complaints of closed environments. They have read the reports from the International Space Station. They know that living in a can changes the body. They dismiss it. But the dust is not done. It settles into the alveoli, the tiny air sacs where oxygen enters the bloodstream. The lungs respond the way they evolved to respond, with inflammation. Immune cells arrive to engulf the invaders. But the particles are sharp, and they are not organic, and they cannot be broken down. The immune cells die, releasing enzymes that damage lung tissue. More inflammation follows. Scar tissue begins to form. On Earth, this process takes years, decades. Miners who inhale coal dust develop black lung disease after decades of exposure. But the dust on Mars is more reactive, and the exposure is continuous, and there is no escape from it. The habitat recirculates the same air. The filters cannot catch everything. Every breath adds another layer. By month 3, breathing requires effort. By month 6, the astronauts are winded after minor tasks. Their blood oxygen levels drift downward. The medical officer runs tests, compares results to baseline, and begins to understand that something irreversible is happening inside them. And this is where it gets worse, because the dust is not only in their lungs, it is in the water. The recycling system was designed for purity. It uses filters, catalytic converters, vapor compression distillation, the same technology that keeps the ISS alive. But the ISS has never dealt with Martian dust. The fine particles pass through pre-filters. They accumulate in pumps. They abrade seals. They provide surfaces for biofilm to form, for bacteria to hide from the ultraviolet sterilization lamps. The water tastes metallic now, slightly off. The sensors show trace contaminants within acceptable limits, but acceptable limits were defined for Earth, for short missions, for scenarios where the crew could be rescued. There is no rescue here. In the power system, the dust is doing what it did to Viking. Solar panels lose efficiency faster than models predicted. The margins shrink. The engineers on Earth run simulations, adjust power budgets, shut down non-essential systems. The habitat grows darker, colder. The crew spends more time in the small circle of light near the critical systems. In the electronics, the dust causes static discharges, not large enough to trigger fires, but enough to corrupt data, to reboot computers, to introduce glitches in systems that were never designed to glitch. The communication array requires repeated cleaning. The rovers outside accumulate dust on their radiators, overheating during the day, struggling to stay warm during the -80-degree nights. The suits are failing faster than expected. Each EVA deposits more dust into the joints, into the seals, into the life support backpack. The bearings in the gloves grind down. The visors become scratched, opaque, difficult to see through. The CO2 scrubbers clog. The cooling systems lose efficiency. The suits were designed for 15 EVAs. They are struggling after 5. And still, the crew must go outside. The mission depends on it. The samples must be collected. The experiments must be deployed. The backup systems must be repaired. There is no choice. The body weakens. The machinery degrades. The margins vanish. By month 9, the habitat is running on critical systems only. The crew rotates sleeping shifts to monitor the life support manually, because the automated systems can no longer be trusted. They speak less now. The effort of conversation competes with the effort of breathing. The return window approaches. The Earth departure vehicle sits on the surface, waiting. It has been waiting since landing, powered down, preserved for this moment. It is their only way home. The checks begin. The systems power up. The propellant tanks are verified. The guidance computer runs its diagnostics. And then someone notices the seals. The dust has been inside the vehicle too. It has been waiting silently for 2 years. It has accumulated on the valve seats. It has settled into the actuation mechanisms. It has abraded the O-rings that separate the propellant from the oxidizer, the cabin from the vacuum, life from death. The vehicle passes its checks. The seals hold for now. But the data shows degradation. The margins are thinner than they should be. The engineers on Earth run the numbers, recalculate, argue among themselves about acceptable risk. They do not tell the crew the full story, because what would be the point? The crew already knows. They can feel it in their lungs. They can see it in the failing systems. They can taste it in the water. The dust has won. It just has not finished yet. The launch window is 21 days away. The Earth departure vehicle stands ready on its landing platform, a silver needle against the rust-colored plane. It represents the sum total of humanity's ability to bring its children home. And it is failing. Not dramatically. Not in a way that makes for obvious decisions. The seals are not leaking, yet. The valves are not sticking, yet. But the telemetry tells a story of degradation that follows an exponential curve. The dust does not accumulate linearly. It accelerates. Each particle creates more surface area for the next. Each abraded seal leaks more path for infiltration. Each clogged filter increases pressure drop, which pulls more particles through. The engineers on Earth have done the math. They have run the Monte Carlo simulations. They know statistically what happens next. There is a 73% probability that the ascent vehicle's main propulsion system will experience critical failure during ascent. There is an 88% probability that the life support during the 8-month return journey will degrade beyond sustainability. There is a 94% probability that at least one crew member will be medically incapable of surviving the re-entry accelerations, given the state of their compromised lungs. The numbers are not shared with the crew, not in full. Mission protocol dictates that probabilities below 50% are not communicated to avoid psychological stress. But the crew is not stupid. They see the power budgets. They feel their own bodies. They know. The habitat has become a hospice. The medical officer spends hours each day monitoring lung function. The decline is measurable and irreversible. The fine particles have triggered a fibrotic response. Scar tissue replacing elastic tissue, stiffening the lungs, reducing gas exchange. On Earth, this condition would be treated with oxygen therapy, with steroids, with the possibility of transplant. Here, treatment means resting, means conserving energy, means watching the pulse oximeter creep downward. Outside, the dust continues to fall. It settles on the habitat dome, dimming the already weak sunlight. It covers the solar panels that supplement the nuclear power. It works its way into the radiators that reject waste heat, forcing the cooling system to run longer, drawing more power, creating more heat. The cycle feeds itself. The crew has stopped talking about the return. Not because they have given up, but because there is nothing left to say. The vehicle will either work or it will not. The seals will either hold or they will not. The lungs will either sustain them or they will not. One of the astronauts, the geologist, the one who spent the most time outside, who collected the most samples, can no longer walk the full distance to the ascent vehicle without stopping to rest. She practices the climb anyway, every day, counting steps, memorizing the handholds, preparing for a journey she may not survive. The others watch her from the habitat window. They do not speak. There is nothing to say. 21 days until the window opens. 20 days. 19. The dust continues to fall. It does not care about launch windows. It does not care about human ambition. It has been falling here for 4 billion years, and it will fall for 4 billion more, long after the habitat is buried, long after the vehicles are sandblasted to fragments, long after the last trace of human presence has been erased by the only true inhabitant of this world. The silence, the patience, the dust. The ascent vehicle fires its engines on schedule. From orbit, the plume is a tiny white flower against the red. The spacecraft climbs, accelerates, sheds its landing stage, and arcs toward the waiting transit vehicle. Telemetry flows back to Earth. The seals hold, the valves function. The crew breathes recycled air through lungs that will never fully recover. They will make it home, probably. Statistically, the margins were thinner than anyone will ever admit publicly, but they held. The dust allowed them to leave. That is the thing about Mars. It does not actively kill. It simply erodes. It abrades. It accumulates. It is not malevolent. It is not even hostile in the way we understand hostility. It is simply indifferent. It has no interest in human survival or human failure. It has no interest at all. The species that built telescopes and rockets and pressurized habitats, that calculated trajectories across hundreds of millions of kilometers, that sacrificed and dreamed and risked everything. That species arrived on another world and discovered that the greatest threat was not the journey or the radiation or the cold. It was the dust on the floor. There is something humbling in that, something that speaks to the gap between our imagination and reality. We picture exploration as heroic, as a struggle against clear enemies. Distance, time, the void. We imagine ourselves conquering, mastering, bending alien worlds to our will. But worlds do not bend. They do not resist. They simply exist, with their own physics, their own chemistry, their own patient processes that have been running long before intelligence arose and will continue long after it is gone. The dust does not care that we solved orbital mechanics. It does not care that we mastered life support, that we learned to grow food in space, that we built vehicles capable of crossing the void. It has its own agenda, which is no agenda at all. It simply falls. It simply clings. It simply wears down everything that enters its domain, including the creatures who thought they could outsmart it. The first humans to walk on Mars will bring that world home with them, in their lungs, in their equipment, in the scratched surfaces of their visors and the clogged filters of their recycling systems. They will carry Mars in their bodies for the rest of their lives, a permanent reminder that the boundary between explorer and explored is never as clear as we pretend. And perhaps that is the real lesson. Not that Mars is dangerous, though it is. Not that exploration carries risk, though it always has. But that the universe does not exist for us. It does not accommodate us. It does not provide clean, dramatic enemies that can be defeated with courage and ingenuity. It provides dust. It provides entropy. It provides the slow, indifferent grinding of physical law against biological aspiration. We will go anyway. That is also part of the lesson. The species that sends its children to Mars knowing the risks, knowing the dust, knowing that some may not return, that species is doing something that cannot be justified by logic alone. It is reaching. It is testing. It is refusing to stay contained by the gravity well that gave it birth. The dust will win in the end. It always does. But between now and that distant moment when the last human footprint is erased, there will be footprints. There will be habitats. There will be voices speaking human words into an atmosphere that has waited billions of years to hear them. And when the dust finally settles over everything, when the last bolt rusts and the last window cracks, and the last trace of our presence is indistinguishable from the surrounding regolith. Mars will still be Mars, waiting, silent, indifferent, and somehow, that is exactly as it should be.